Okay, factoring trinomials. So let's say that f of x is equal to x squared minus 6x plus 5. So I actually only really care about the first thing and really more so just the last thing, this 5. First thing I want to do is I want to list the potential factors of 5, and those are plus and minus 1 and plus and minus 5. We're going to be doing a lot of listing the potential factors. So, for example, in this line, if all I had was x squared and 5 at the end, it could factor to be x plus 1 and x plus 5. Or it could be factoring to be x minus 1 and x minus 5. Because if we FOIL it out, all we ever care about is x plus a times x plus b to equal x squared ab. So we know our last number is always a product of the two factors. Always a product of the two factors. So, as we learned in the factor and the remainder theorem, I want to test out my potential factors of my potential zeros of 1 and 5 by substituting into the equation. Let's start with f of 1. So if I take 1 and put it into the original equation, 1 squared minus 6 times 1 plus 5, and f of 1 is therefore 1 squared is 1, negative 6 times 1 is negative 6, 1 minus 6 is negative 5, plus 5 is 0. So I proved the factor theorem. F of 1 was equal to 0. So I know that x minus 1 is a factor. Now, in the notes it says stop here if you want and go straight down to long division, and that's what we're going to do. But in the notes, it tests out f of negative 1, and it's equal to 12, so x plus 1 is not a factor. And then it does f of 5, and that's equal to 0, so that x minus 5 is a factor. And down below, I did the synthetic division with the 5, but I'm not going to do both. So let's continue with x plus 1. So I set that equal to 0, and I solve, and I get x equals 1. And then I put that 1 into synthetic division with a plus sign. And then I list my coefficients. 1x squared, so 1, then negative 6, then positive 5. Bring the 1 down. 1 times 1 is 1. Bring the 1 down. 1 times 1 is 1. Negative 6 plus 1 is negative 5. 1 times negative 5 is negative 5, and 5 plus negative 5 is 0. As we knew, our remainder would be 0. So, remember the coefficients go down by 1, so I'm left with 1x minus 5. And I could write a division statement, x squared minus 6x plus 5. Divided by the potential factor of x minus 1. I knew it was a factor because we got 0 for a remainder, and we're equal to x minus 5. Keep in mind, we could write it in the different form and times those sides by x minus 1 and write it in factored form, which, as we remember from grade 11, if we set our factors equal to 0, we get x-intercepts at 5 and 1. And as you can see, off to the right, I've drawn the graph perfectly, but let's just draw it a little bit more casually. X-intercepts of 1, 2, 3, 4, 5 with a parabola. Keep in mind, we're concerned with this x-intercept. I was really lazy. Take a look at the graph or do a table of values. But the most important thing was we successfully factored the initial trinomial from the beginning by listing the potential factors. Let's work in big blue. the factors of the last thing, 5, are plus and minus 1 and plus and minus 5. So then we test our factor theorem by substituting x values, and if it equals 0, we know that x minus 1 is a factor. Then we do synthetic division, find out our other factor, then write a division statement, and finally a multiplication statement. Set our factors equal to 0 and get our x-intercepts, and plot the x-intercepts as we did in grade 11. Okay, factoring quadomiols. I don't even know if that's a title. The last one was factoring trinomials. We did it doing grade 12 methods of synthetic division. Now we're going to see a grade 12 question. F of x equals x cubed plus 2x squared minus 5x minus 6. And again, all I really care about is f of x equals x cubed dot 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 minus 6. And I can list the potential factors of minus 6. And the potential factors of minus 6 are plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. The potential factors. I've done a little bit more theory off to the right with all the different examples we could have with the minus 6 last, and again, how the last number, negative 6, is the number that you get if you multiply out all the factors. So let's test f of 1. So f of 1. And then we substitute 1 in for x. And f of 1 is 1 cubed is 1, 1 squared is 1, 2 times 1 is 2, 1 plus 2 is 3, negative 5 times 1 is negative 5, 3 minus 5 is negative 2, minus 6 is negative 8. So we know x minus 1 is not a factor. Not a factor. So we're done with that one. Now let's try negative 1. F of negative 1. Well, let's substitute negative 1 in for x. So substituting negative 1, making sure that we use the proper substitution with brackets. So f of negative 1 is equal to negative 1 cubed is negative 1. Negative 1 squared is 1. 2 times 1 is 2. Negative 1 plus 2 is 1. Negative 5 times 1 is negative 5. 1 minus 5 is negative 4. Negative 1 plus 2, negative 1 plus 2, substituting negative 1 in for x. Let's do that again. Negative 1 cubed is negative 1, negative 1 squared is 1, 2 times negative 1, 2 times 1 is 2, negative 1 plus 2 is 1, negative 5 times negative 1 is positive 5, and 1 plus 5 is 6, and 6 minus 6 is 0. So we know that if f of negative 1 is equal to 0, the factor x plus 1 is a factor. So if we know that x plus 1 is a factor, then we can go ahead with our synthetic division. So if x plus 1 is a factor, I set x plus 1 equal to 0, and if I subtract 1 from both sides, x equals negative 1. And that is the value that I'm going to put into synthetic. So negative 1 with my L and a positive sign. Now list my coefficients from above. 1, positive 2, negative 5, negative 6. Bring the 1 down. 1. Negative 1 times 1 is negative 1. Positive 2 plus negative 1 is positive 1. Negative 1 times positive 1 is negative 1. Negative 5 plus negative 1 is negative 6. Negative 1 times negative 6 is positive 6. And again, we get a remainder of 0. And remember, these are the coefficients of the term, and we used to be x cubed, so we're 1x squared plus 1x minus 6. Now, remember from grade 11, that factors again. We could do it all, but let's just do it. So two numbers that multiply to get negative 6 and add to get 1 are x plus 3 and x minus 1. Excuse me, x minus 2. And then we can list our other factor beside it, x plus 1. Therefore, the question that we began with is fully factored to that. And if I set all my factors equal to 0 and solve, I get my x-intercepts of negative 3, x equals 2, and x equals negative 1. Be really careful setting those equal to 0, because when it gets more difficult, make sure you actually set it equal to 0. Each one of them separately. Make sure you also graph it in your graphing calculator. But we're going to graph our x-intercepts at negative 3, at negative 1, and 2. And I'm just going to quickly graph it. It's not perfect at all. The y-intercept is terrible, but we have our x-intercepts at negative 3, 2, and negative 1. Put it in your graphing calculator, make sure it looks right. Now we can fully factor cubics. In grade 10, we did lines, y equals x. In grade 11, we did y equals x squared. In the past few examples in this chapter, we've taken a look at x squared and x cubed, but we've finally now fully factored a cubic, and we know what those x-intercepts are. Okay, a brief bit on potential factors. So let's go for f of x is equal to x cubed plus x squared minus 8x plus 4. And remember, we list the potential factors as the potential factors of the last number, so plus and minus 1, plus and minus 2, plus and minus 4, our potential x-intercepts and therefore factors. So we would solve by inspection. And we do that in the notes by testing f of 1, and in the notes you can see f of 1 is equal to negative 2, so x minus 1 is not a factor. Then we test f of negative 1, f of negative 1, and we get 12, and x plus 1 is not a factor. Then we test f of 2, and we get 0. Therefore, x minus 2 is a factor. Using the factor theorem and the remainder theorem. Now, briefly, on the next example, if f of x is equal to 3x squared plus 5x minus 2. Notice we have this coefficient out here. So the first thing we do is we list the factors of the last thing. The factors of the negative 2. And those values are plus and minus 1 and plus and minus 2. But we also have to list the factors of the last thing over the factors of the first thing. And the factors of the first thing are plus and minus 1 and plus and minus 3. Now we put the first factor, 1 over 1 is still 1, so we don't bother listing that one. But we do have to put the first factor over the last factor, so plus and minus 1 over 3, and the second factor over the last factor, plus and minus 2 over plus and or 3. So those are the potential factors. And you'd actually have to test all of those values. I haven't in my notes. Sometimes it's not upgraded enough. I just wanted to include that. Sometimes that's a multiple choice question, or sometimes, I'm not exactly sure, but you may get some x-intercept like, or factor like 2x plus 1 if f of negative a half is equal to 0 by setting the factor equal to 0 and solving x equals negative 1/2. So that may be the case, and that would be really annoying on the test, because if you try 1 and then 2 and then a third and it doesn't work, or whichever it is, so I should have done 3, I should have done 3, 1/3, because I was testing this potential factor, Just out of this notes, just remember these are the potential factors, substitute appropriately, do any algebra necessary, and if that is true, then we know that this is a factor and this is an x-intercept. A little bit tricky.